minute or second or hour, whatever may be, is proportional to A multiplied by d by dt of x of t. Correct? Where A is called as the area of the piston. Piston is, you know that it is circular in correct shape. Correct? It has some width, and this side is the area is circular because so that once radius or diameter is given, automatically you can find out the area. A can be found. Once you know the area of the piston, then if you multiply it by d by dt of x of t, where x of t is the position, correct, of the piston, and d by dt is nothing but velocity. I say v of t. So I can say that q equal to a into v of t, where v of t is velocity with nothing but d by dt of x of t at the position. So this is one equation. Okay. The other one is, this is flow rate versus the velocity. Similar to previously. Here also we saw flow rate versus angular displacement. Correct? And here we are talking about flow rate versus velocity. That means if I want the pistons to move faster, I have to, for a given piston area, that is fixed already, you have this one. By varying the flow rate, I can vary the velocity of the piston movement. Similarly, when I talk in terms of force generated by the hydraulic cylinder, this force is what going to drive my load. Correct? The force is important. Force and displacement, and d by dt of x of t is nothing but velocity. All these things are related. So force equal to P into A, where P is the pressure of the fluid and A is the area of the piston. So this is second. That means I can have two mathematical models. One based on flow rate versus velocity. Other one is flow rate versus the force generated. Force is the output. Okay. So now I can, that's what you written here. Flow rate Q equal to A into d by dt of x of t. So I take Laplace transform of this, then I will become Q of S equal to A into d by dt will become S multiplied by x of S. Okay. So this is in Laplace. Then from this I can write G of S equal to, I can say this should be written as, sorry, it should be capital X of S divided by Q of S. I told you many times we don't write within bracket S, and here also T, time domain, frequency domain, you can write, otherwise you can leave it also, well known. At least somewhere you have to show that it is a Laplace. That's why you put G of S within bracket, it is in Laplace domain. X of S divided by output divided by input flow rate equal to 1 divided by A into S. So this is the transfer function for the flow rate versus the velocity of the piston. Other one, the equation already written, F equal to the second one equal to force generated equal to P into A, where P is the pressure of the fluid, A is the area of the piston. So then I can write transfer function in terms of force generated output divided by input pressure equal to just area. So if I want more force for the given pressure, I should have a bigger piston area. Or already I have piston cylinder made, the actuator is already ready. If I want more force, I increase the pressure. If I increase the pressure increase means automatically force will increase. If pressure decreases, force will decrease. So in the force generated proportional to pressure. Similarly, their torque and force are for this one. One is rotary force and linear force. Already we saw that. So this is the mathematical model of the hydraulic cylinder. Now I wanted to, because I already told you, I wanted to, this is my flow metering valve along with actuator. Actuator is nothing but hydraulic cylinder. Already we saw the model. Additionally, I wanted to control the direction of the movement. Correct? I wanted to move left to right or right to left, depending on, because one side movement is not sufficient, because that means only one time I'll be moving. So I need what you call as control valve. This is called as control valve. Correct? So control valve controls the amount of the fluid coming, flow rate, and correct, and which direction it enter. For example, this is port A, this is port B. Which, depending on direction you want, you have to allow the pressurized fluid fill the particular chamber. If I fill the particular chamber B with pressurized fluid, piston will move like this. Instead of that, if I fill the fluid using this port, and piston will move other direction. So for that, we have control valve. So this is the control valve. The control valve consists of, again, it is a hydraulic system only, but it is smaller in size, very, very small compared to the in fact, sometimes in the, if you talk hydraulic, they call power cylinder. They will call power cylinder because this is going to generate power, which is now force multiplied by displacement. So the movement is created with a force, and the load is here. My load will move left or right because it is connected. So that's why this is called as, the actuator is called a power cylinder. This is a valve, but they don't call this cylinder, but it's a valve. This valve has, you can have 5 ports. Correct? It has a body. You can see that this is the body, and inside which there is a piston arrangement. Correct? But there are 2 pistons connected to the common shaft. Correct? 2 piston. You can say this is one piston, this is another piston. A common shaft is connected. The shaft is brought out. So this one inside the cylinder, you are going to fill the fluid. Okay. This has 5 ports. The valve itself, they call the hydraulic valve. It is called directional control valve, and also control flow rate. It control direction and flow rate. Okay. Now the pressurized fluid, this inlet port, here the high pressure fluid is coming. High pressure fluid is coming from the pump. Pump sucks the fluid from a tank, pressurizes, the pressure fluid comes here. I say P equal to, say, 10 bar. 10 bar pressure fluid is entering through this into the valve, and it waits here. It cannot go anywhere. Why? You can see that. So this is pressurized fluid inlet, and this is called drain ports. There are 2 drain ports. Then the pressurized fluid will be connected to the hydraulic cylinder to the other 2 ports. Correct? These are 2 ports, and I say that X and Y, for example, you can give any name. I'm giving X and Y. So now the pressurized fluid enters, and it is here. Okay, and you can see that, in fact, this is called as spool. Correct? The 2 piston connected in a common shaft used to control, close and open the outlet ports. So we can say X and Y are called outlet ports. Outlet ports of the valve. Correct? This is inlet port. I can say P1. These are called the P2 and P3. These 2 are called the drain ports. This is called an inlet port. Correct? P2 and P3 are drain ports. P1 is called all 3 are inlet ports of the valve. There are 2 outlet ports I call X and Y, and these outlet ports are connected to port. For example, this is A and B of the power cylinder. Okay. Now, and now as I told you, this is called as spool. Right? Spool, when it is inside, the spool remains in center of this one, and you can see that when it is in center, because this closes, the pressure fluid comes here, but it cannot go inside the power cylinder because the spool is stopping. Similarly, this also closes this. Here nothing can go. So both the X and Y outlet ports are closed when the spool is in the center position. Now it is in center position with respect to this hydraulic valve. Okay. Now what I do is, if I want to the fluid coming, pressurized fluid which is here, to come and to enter into here, that means this valve should open. Correct? This port should open. In the case, what I will do, I have that is electric solenoid. Electric solenoid will be used, and when I give the electrical power to solenoid, it will generate magnetic field which will push the solenoid stem. The stem is attached so that the spool valve moves. That means what it happens is, now if when I give the displacement like this from using another this one, whatever this one will be moved like this. It becomes like this. You can see the new position of my spool is like this, and it comes. You can see that this is a new position. Originally, it was in center. Now shifted to some displacement X of Y. I say the 5 mm. Then what happens? Now the port is open. Which port is open? And that's what this in X and Y. Y port is open. So the pressurized fluid can enter and go into this chamber. So then the pressure is applied. The power cylinder piston. This is the power cylinder piston moves from right to left. So it is this one. At that time, already please note that this will be filled with oil. Both chambers will be filled with oil. Here the pressure is less. Then the whatever the pressure is here, low pressure fluid will go out of this chamber, enter and go to the outside tank. So that means pressurized fluids enter to this port. From the inlet port, it enters here, it comes here and moves this one. Now, if I wanted to move the piston from left to right, what I have to do? Very simple. I will move the spool valve towards like this. That means moves this one by applying a force in this direction. There's a displacement direction. My spool valve moves like this. Now you can see that the pressurized fluid from here can go through this and enter and applies force. Force is applied here. Pressure is there. So the piston moves from this one. During the time, whatever the fluid here will just go through this and go through drain. So by controlling the direction, that means how I am controlling the power cylinder of this one? By moving the spool valve, correct? Spool of the this valve. Direction control valve. And if I move, how much this is opening, correct? I can move little by little. I can move little by little, correct? I can fully open or partially open. So the quantity of fluid Q can be controlled by controlling this position. I'm not going to move step. Any position I can open. So the Q, so many liters of fluid moving inside this one is what. So that means this velocity is controlled. And also which direction is moving can be controlled using this valve. Correct? They call directional control, flow control valve. Okay. So that means now what I have is, we know the mechatronics system means you have a mechanical system and it should be powered by a actuator. I have the actuator. The actuator should be controlled using a control system. So this is a control valve. They call it a control valve. So now we have to write the model equation for the power cylinder with control valve. Okay, so in that case, we know that with respect to flow already we know, correct? So we are giving input to the control valve is x of a position of the spool. That is input. In that case, my Q varies, correct? My Q varies because how much the valve, the port is opening, whether it is fully open or because by moving this position, any direction, the valve opening is controlled. Once it's controlled, automatically flow rate is controlled. So if I control, how I am controlling flow rate? By controlling this one. So this first equation talks about Q equal to kV into Xi, where kV is called a valve constant. kV is called as valve constant. The valve manufacturer, if you buy a flow control direction valve, they will give what is the valve constant. That if you once that is known, then we can find out Q equal to kV into Xi equal to A into d by dt of x naught. What is this? Area of the power cylinder. This is the area of the power cylinder. That is capital A, d by dt of x naught. X naught, the position of this, right? Position of this piston. That is nothing but here I am attaching my load and also the load is moving. That is x naught. Input to the whole system. Now, whole system input is x of I. When I change my x of I, accordingly Q varies. Q is varying. If Q varies, x naught will vary. X naught varies means d by dt of x naught is nothing but velocity. That's what the equation. Note down this. Correct? If I vary the flow rate by controlling the xi, control parameter position of the spool valve, if I control vary it, and the amount of output is Q, flow rate for this system, input is spool position, and how much quantity of fluid is entering, coming out and entering into this one, that is this one. So this part talks about model of this. Okay. And then if I vary this, automatically the x naught is varying. That is talked about here. X naught, d by dt x naught, nothing but a into v naught. Correct? This is called, I can say v naught is the velocity of the piston, right? Power cylinder piston, which is connected to this one. So now we have written the time domain equation. We need to write the, again, you can see that kV into xi equal to a into x naught. I have converted this is a time domain equation into Laplace. We know that we can write kV will become valve constant, will come as it is. Xi is a multiplication, so it comes as no portion of this one comes as it is. A is the constant, will come as it is. D by dt is represented by Laplace variable s. Then x naught is given here. So now I have the Laplace domain equation, same mathematical model or mathematical equation written Laplace. How we can find out transfer function? Already we know transfer function g of s of the whole system is nothing but the output of the power cylinder, or position of the output is divided by position of the spool valve. Correct? Spool valve of this one, that this one. So if there is nothing but 1 divided by a into kV multiplied by s. From this only we are getting this. Correct? So I can write again same thing. Transfer function of the entire system is x naught by equal to 1 by ts, where t is called a time constant of the entire system. Correct? It is called time constant system, which is nothing but a by kV, where kV is called valve constant. Note down. The valve constant will be given by manufacturer. One that is not, then you can write the transfer function and you can find the time constant of the system also. Okay. So already told, output of the power cylinder piston is called x naught. That is my output, and the constant pressure flow rate is proportional to valve position. So the velocity, correct, of the piston can be controlled. Okay, we see this one example unit is meter per second. The valve constant will be given by the manufacturer. Can I go to next slide?
Sir, I have a question, sir.
Yeah, yes, please.
Sir, do pardon me if it is wrong, but there is our braking system is also somewhat similar only, sir.
Right.
So, like I was just wondering if the output XO is already known, then having just one proportional constant like kV would not be sufficient to control the system, right? Like there will be some chattering in the output or something. So we might need like a integral part or like a second order system to define the whole thing. I might be wrong. Hence
no. See, here we are trying to consider a simple this one to understand how, because many of the parameters theoretically we have just forgot. The friction we are not taking at all, right? Friction we are not taking. We are just talking in terms of what do you call this? Excuse me?
Connected suddenly.
Teams call. I don't know how it is connected. I don't know. I didn't connect it.
Okay.
No,
you are correct. What your question asked, we need to have more model. This is a simplified model to understand how the actuator with valve can be modeled and how to develop mathematical model.
Understood.
Detailed model, because you know that as you go friction, many things you have to consider, leakages, many things you have to consider. It becomes a second order, third order system. Then control is not easy. Correct? Here we are talking about simplified control, and this is for understanding. Correct? Mechatronics, how to model system. While modeling system, you have to model the valves, you have to model the actuator, you have to model the system, the mechanical system, and you model the control system, and everything can be simulated using virtually. You make entire system virtually, and so that in the computer itself you optimize each and every parameter. So if you want a particular output, and because the parameter what you are talking is area, force, because I want to control what is the force generated, and once force is this one, that is proportional to area of the piston. Correct? I can optimize what is the area without making the actually the cylinder itself. If you are designing the system, you can each and every this one component. Correct? All this thing can be optimized using mathematical modeling without building the actual system. The whole idea is developing any individual system or a component or a whole system using mathematical equation, running the program in the computer, and so that quickly, if I want more force means I will change A. I know the diameter, correct? Then area, you have the equation. You may vary this equation, write the program change this constant. If you D you vary, automatically A will vary. A varies means then the entire equation in few minutes you can model and see the result, what happens, what is the X naught, correct? That is the advantage of having modeling and simulation. Otherwise, before computers are not available, some 50 years before, everything you have to make physically or calculate manually, and you have to check making the prototype, physical prototype. That is now avoided. That's what we are trying to understand. Okay. So next one is, yeah. Now we started with power cylinder, correct? Only actuator. Then we added control valve. The model we got it. Then next thing what you are trying to do is we are adding load also. If I add load, correct, my system become complex. So you have the control. What I saw previously, again same power cylinder. Only thing is I added mass. And it also, as you told, now you can see that I added damping also. Correct?
Okay.
It is moving with this one. The mass is moving inside a cylinder, and there's a friction in the valve. Correct? So that is we call it damping. Friction is called damping. So I added additional damping. This is load. Load is moving inside a cylinder with some friction that we call damping KD. Now, if I write the everything I explained, correct? Pressure equal to KV into XI. Correct? Pressure of the fluid coming here. From here, high pressure fluid is coming. I am controlling this valve. So we can enter the fluid from the direction, enter here. Or if I allow the spool to move towards left, then the fluid, it will come here. The both direction already we saw. I can control this doing. Everything is same. Okay. Only thing is we have added this one. Now applied force. Force applied on the power cylinder. How much force is there is pressure of the P is the pressure of fluid. A is the area of this piston. Correct? This piston area is A, and so that the mathematical model in terms of force generated by this one, which is pulling this. Correct? So if force is generated to this, the mass will be moving like this because the piston is moving. Both way I can move this one. I wanted to move from the center position. I want to move the mass inside this one, left or right. This is 0% center position, plus side or minus I want to. That means by controlling direction of fluid, whether it enters here, this one, I can move this one because the hydraulic power cylinder piston is directly connected, attached to mass. Mass also moves. So the X naught is same as the position of the mass. So that's why now we know that there are additional forces are acting. We know that, correct? Now we added a mass. Till now, we never see. Please note that as you ask right question, even this piston has a mass. Correct? This also every mass is that we are not considered in the previous equation. Correct? We are talking in terms of just displacement and pressure and this one. But in this case, load mass is heavier compared to this piston mass. Load mass may be very heavy. That's why we cannot ignore it. And that's why we put inertial force due to the mass. That is nothing but m into a d square by dt square of x of t. X of t is nothing but x naught, you can say. It is nothing but x naught because these are similarly the mass is moving inside the cylinder, some with friction damping. Correct? The damping force due to this frictional constant, damping constant is kd into d by dt. X naught is nothing but velocity. M into a, this is kd into v. This is acceleration. This is velocity. The damping force is kd into velocity. Inertial force due to mass is m into a. So these two forces are opposing this motion. Please note that this motion is created by this force. This force is created by this pressure. Okay, that is fluid pressure. And now if I try to move here, this mass and these two forces will oppose this motion. So that's what we are writing equation. You can see here. Now PA, correct? PA is the force, FB, force generated. That is input for the entire system. PA is the force generated by power cylinder, is proportional to pressure of the fluid and area of this piston. Okay, equal to the opposing force, because this is trying to move like this. This is my FP, correct? Equal to Fi plus Fd. These two are, that means I can write this Fp minus Fi minus Fd equal to 0. only when these two forces are opposing the motion towards left. So for that I am writing equation, correct? This is my Fp, this is my Fi, this is my Fd. So now we already know that we can write this equation. We have given equation from the kV into xi into a, correct? kV into xi into a is the force that depends upon kV is the wall constant, correct? kV is the wall constant, xi is the input. So kV into xi is going to decide what is the P, pressure of the fluid entering, correct? Pressure of fluid, that means valve opening. This valve opening going to decide how much fluid with the pressure is entering here. That is controlled by xi, correct? So, and the valve has a valve constant. If I can multiply it by this A, correct, then I know the total force Fp. It can be written. This whole term is Fp. Okay. Now equal to Ma. Now that we know that this is written in time domain equation, I want to find the lab transfer function. Easy to use. First convert the differential equation. This is second order differential equation to algebraic equation. I can write this kV into xs, sorry, x of s into a equal to this. M is as it is, d square by dt square will be Laplace by s square. This x naught will become x naught itself plus kd. The kd is a constant, come as it is. D by dt will become s. This x naught will come here. So this is my Laplace equation. This is a time domain equation. I convert it to, this is a differential equation, convert to algebraic equation, simple algebraic equation. Then I can find the transfer function g of s is nothing but output divided by input. This x naught divided by input is the spool position. This is the position of my mass, which is nothing but the power cylinder position is same as because it is attached by a solid rod. So the mass also moves same. The displacement of the load or the power cylinder is same. X naught divided. This one is 1 divided by m by a into kV s square plus kd divided by a into kV into s. This is what I do. So which can be written as, I can write g of s equal to 1 divided by ts square plus 2 delta ts. I can write like this, where t square equal to m by a into kV. That means t equal to, you can, this leads to t equal to root of m by a into kV. This is called a time constant. We will know time constant as an effect on the system output, that we will talk when after control system. Okay. So if you give a step input, the cylinder, see, I gave you suddenly I moved the piston, correct? The spool valve by say 5 mm, because the spool valve xi will generally vary from center position plus or minus 0 plus or minus 10 mm. The spool valve moved very, very small. From the center, this is my center position, it can move this side 10 mm, that means fully open, correct? So all the fluid can go with maximum pressure, correct? Instead of that, I can move this side, this spool valve will come here, correct? So that all the fluid can go here. This is closed. It goes here, and that's how it works. Now, if I give a sudden step input in the xi, the x naught will not be like this. It will be something like this. The power cylinder movement, this x naught may move something like this, or it can move something like this. It can oscillate also, depending upon model. This is a second order system. Definitely, the position of the power cylinder will be moving something, oscillate like this. And whether it be like this or something, that depends on what you call damping ratio. That depends upon damping ratio. We can discuss about it because we don't have time. Correct? That is a big area which this was, since somebody was talking about the ABS using hydraulic only, especially
Yes.
commercial vehicles. Correct? So
the diagram what you drew was what I was referring to, sir. That is where my head went.
Yeah.
So, like that unsettled part you drew in the end, no, sir. The damping, the unsettled part what you drew in the end before erasing. So that is what I was imagining. If we just use like a damping ratio, which will just be like a proportional input. So if that is
not
not
sufficient,
accurate, then
I know we need to go for PID controller, at least,
yes,
or PD controller. We have to go for PD or PID control, because see, I am working this control system for last 25-30 years. Not only mechanical industries, I worked in many area I work. Okay. Maybe if you want, you can come and meet me and discuss. If you in your company wants, we can discuss that also. Okay.
Yes, sir. Thank you, sir.
Yeah. Anytime you can approach. But only thing is your company should be ready for that collaboration. We can work on it. Okay, fine. So now we know that T is called time constant. T square is equal to m by this one. That means if I want to find the T, this will become root of, correct? Because the time constant proportional to the mass of the load, and A is the piston area, and K is the valve constant. This is valve constant. This is the area. This is mass. All three area values going to decide your time constant of the system. Okay, and here, then one more thing also, CC is called critical damping constant, which is written as root of 4 MA into KV. Correct. So please take the all the equations, the derivations. In the exam, you may be derive the mathematical model of hydraulic this one cylinder driven by a valve, correct? A control valve, and which is moving a mass having M. Draw this one, derive this equation, transfer function, calculate T of the time constant of the system. Once the value of M, A, KV, all these things, whatever you need, if I give, you need to find out. Then CC is the critical damping constant, which is another 4 into root of 4 into MAKV, and the damping ratio delta equal to KD divided by CC. The damping ratio only going to decide the output response, whether oscillate, all those things will be going to decide this. And that they have to be modeled more accurately. Many things we have to do. That we'll see later. But please take down the equation and the derivation. In the exam, you can expect questions like that. Draw the functional block diagram. This is called functional block diagram of a hydraulic cylinder. Actually, system is nothing but here cylinder driven by valve, directional control valve, correct, and plus load, correct. So that means the rough sketch. I don't worry, but in the exam I'm not going to ask you to put a scale and draw, but neatly draw what this is. Then derive this equation starting from here to correct. Come here. This finally G of S you have to write, and once value are given, you have to find the T and the C and the delta. Delta is called damping ratio. CC is critical damping. Because you want to find out the D, you should find out CC. Only then you can do. Then you can find out. Then KD will be given. Then you can find the time constant. Okay. So we go to the next slide.
Yes, sir.
Okay. Now that we saw the mechanical control, hydraulic control system, correct? Hydraulic components and controlling, hydraulic actuator, hydraulic valve, controlling all these things. Because in mechatronics, you are going to see control circuits also, correct? You have circuits, motors, all these things. In that case, we need to how to model electrical circuits. Please note that I am just touching upon to understand what is the mathematical modeling, how to develop a mathematical model of individual system, individual component, small mechanical system, small electrical circuit, small electrical actuators like motor, RL circuit, all those things. This is only to give an idea, correct? For your system, you will have maybe more than 10, 20, 30 components. Then you have to build complex system, complex mathematical equation that you have to do. So when we talk about electrical circuit, the basic components are basic building blocks. Basic building blocks are components are resistor or inductance L and capacitance C. Resistor generally shown like this in the electrical circuit, and they will given a value, for example 10 ohms, unit is 10. Next one is inductor. It will be shown like this. It is inductor shown like a coil, correct? This is this one is the induction value given Henry's. Okay, this is a person name who the inductor, so honor him, they given Henry's. The ohm, correct? Also the scientist who invented Ohm's law, to honor him only the unit ohm is used for resistance. The third one is capacitor. Capacitor is generally represented like this. This is a capacitor. Okay, capacitor unit is farads. You know Michael Faraday. So farads. Okay. So to honor him, the given name unit of capacitance is 1 farad, 2 farad, like this, millifarad, microfarad, nanofarad, picofarads also it can go. So these are the basic symbol, basic units. So that means if I see any electrical circuit, the components can be removed, correct? You have a transistor, you have a diode, you have a MOSFET, you have like that component, individual components. Those components can be broken down to basic components. The basic components are R, L, C. Resistor, inductance, capacitance. They call building blocks of this one. Transistor can be finally written as a what you call equivalent circuit. Equivalent circuit will consist of only resistor, inductance, capacitance. We are not going deeper. That is not our job. That is semiconductor physics. Electronic students will be doing. But here we are talking the basic electrical circuit, how we can develop. Here we have two circuits. The first circuit called RC circuit. That is when this is R, resistance capacitance circuit. I call it as RC circuit. Correct. Full name is resistor capacitor circuit. Short form, the RC circuit. It consists of one resistor and one capacitor. For this, I am giving input voltage. Electrical system input is always voltage. You supply voltage, the output is the current. Correct. So the system component R and C. Okay. Now, here you can see that VA is input voltage. For example, I am giving from a battery. Correct. Battery I am giving 10 volts. My resistance is equal to 10 ohms. Okay. The capacitance is, for example, 5 farads. Okay. Now, what I can do, that means once this voltage is applied, a current will flow through the circuit. That is called I. Due to current, a voltage will be developed across this capacitance. I say that is VC. Similarly, there will be a voltage developed across capacitor VR. So I can write, yeah. So I apply the input voltage due to there's a current flow. Since same current is flowing to resistor capacitor, there are two voltages developed across two components. Correct? That is called generally in the electric circuit, the voltage drops across circuit or loop. Closed loop. In fact, they are called as closed loop. So the voltage given plus this one, from this is enters to resistor, current enters and enters the capacitance and comes and completes the circuit going this negative terminal. So we call this is called a circuit or closed loop. Okay. Now the voltage across a closed loop circuit is given by what we call a KVL. This is called Kirchhoff's voltage law. Short form is KVL. According to KVL, this is input voltage VA, correct? This is VA. VA equal to voltage drop across this the components of this one. There are only two components, resistor and capacitor. This is voltage VR across resistance, which is nothing but current multiplied resistance value, correct? IT, this is IT. Okay. IT is the output for the circuit. Input is voltage. So VA equal to voltage across this resistance and voltage across capacitance. That is nothing but 1 divided by C into integral IDT. IDT is current. Integral of that multiple 1 by C. C is the capacitance value. So now we can write this. This is in time domain equation. Correct? We are talking time. You can say within bracket T in time domain. I take Laplace transform. Correct? Then it becomes V of I equal to IR plus I divided by CS, correct? I divided by C. The 1 by C, actually, how it came is 1 by C multiplied by integral term is there. If integral term is there, then it will be 1 by S. You have to multiply it by 1 by S. Multiplied by I of T will become I of S. That's what is written like this. Correct? So I in the numerator, C S in the denominator. So this is my Laplace equation. Now, in both I is common, I can take it out. So VA equal to I into R plus 1 by CS. So this is my mathematical model of this electrical circuit in Laplace domain. Okay. From this, I can find the transfer function. Transfer function of the circuit. What is transfer function? I told you, transfer function can be called as the gain of the system. Okay. that is nothing but output divided G of S, the transfer function or gain of the system is nothing but output divided by input. What is the output? This V naught. Correct? V naught is nothing but voltage across this capacitor. This voltage only we are taking as output. Correct? So this voltage divided by this voltage. Correct? I can write. We can write two equations. V, correct? V is the input, I is the output for the entire circuit. I can write equation I by V also. That is my G of S. Otherwise, in this case, I have decided this is my output. I am supplying some input due to that there's a current flow I, and there are two voltage VR and VC. The VC voltage is my interest, not the current. My interest is V naught. V naught is nothing but voltage against capacitor. In that case, I can write the transfer function like this. Correct? Don't get confused. I can write I by V equal to G of S. Correct? From this equation, I can write. Correct? Instead of that, I can write V naught is the voltage across this. I can write like this. In that case, the equation was I divided by CS divided by R plus 1 by CS, which can be written 1 divided by RCS plus 1. This is the transfer. So this is the final transfer function. Okay. So where T is called a time constant of the system. Note down. Time. See, we saw the time constant previous hydraulic system also. Mechanical spring bar damper also we saw some. So electrical circuit also will have time constant. Where you will find the time constant, whether it's a hydraulic system or a mechanical or electrical system, if the system has any energy storing device, then there will be a time constant. Here, the capacitor is a electrical energy storing device, which stores the charge. Charge is nothing but the current itself is rate of flow of charge particles. Charge particle is nothing but electron. So the capacitor shows a electrical charge Q. So that means since there's a one storage element, automatically there will be time constant. Correct? The time constant T. What is T here? This is T. T equal to R into C. Resistance value multiplied by capacitance value. Correct? So now I'll take 1 more minute to complete another this one. What is time of? Okay, faculty will be waiting. We'll see tomorrow.
5:53.
Okay, sir.
Yeah. Thank you. See you tomorrow.
Thank
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah. Take care.
Thank you, sir. Thank you.
Yeah.
Thank you, sir.
Give your attendance as a chat message. Don't forget.
Yes, sir.